Okay, so this is your video for the basic linear games. We're going to talk about toy tracks. So let's go. Alright, so here's the game. This is prep test 30, the game 4 in the section 1. That's going to be page 53 of your prep test book. So it's a question about toy tracks. We have 7 toy tracks: F, G, H, K, M, and S that are in 7 assembly line from 1 to 7. The 7 lines are blah blah blah. 1 to 7. Here are the following conditions. Rule 1 is that F is always before J. Rule 2 is that M and J are together in this order. Rule 3 is that H is either in 1, 2, 3, 4, 5, 6, 7, either in H or it is in the 7th spot. And rule 4 is that S is a symbol 3, so H is 1 or 7, and rule 4 is that S is in 4, 1, 2, 3, 4, S is right here all the time. Okay, those are the rules, so now let's move to the questions. This is your main diagram, those are the main rules. Question 17. Question 17 is your orientation question. It asks you about the possible combinations. As usual, you apply the rules to. Oops, I'm sorry. You apply the rules to the combinations and not the opposite. So let's look. Let's look at rule 1. If you look at rule 1 at the series of combinations, so you have A, B, C, D, E. Rule 1 rolls out E, in which F is after J. Rule 2 rolls out C, in which M, G are not stuck together in that order. Rule 3, which is that H is either in 1st or 7th position, is going to roll out A. And then rule 4, which is that S is in the 4th position, is going to roll out D. So the only one that you have left after looking at this is answer B, which gives you an example. So again, highlight on your book, highlight this example of an acceptable combination. Okay, so that's for question 17. Question 18 now tells you it must be true that the lowest number line on which, and then a series of options. So let's look at them. That F can be, and the lowest number for F is 2. The lowest number for F is 2. No, F could be in the 1st position when H is over there. There's no reason why not. That G can be, that lowest number for G is 3. No, again, G could be in 2, right? Because MG could be here if if H is on the other side. Answers C, that J is assembled in line 2. That might be the case. Could J be lower than 2? Could it be in 1? No, because F needs to be there. So that is your answer, which is C. Let's move to 19. Question 19 is if K is on 5. So this is a case where you're going to have a sub-diagram, you have a completing question. So you're going to do your sub-diagram, and not only you're going to have a sub-diagram, but you're going to split your new diagram because of those 2 options with the H and H here. So you're going to have 2 sub-diagrams, one which puts you H, and then 2 spots SK, and then 2 spots, and the other one which is going to be 1, 2, 3 SK, 1 spot, and H. Alright, so K is on line, S is on 4. So what happens now? Well, we know that we have MJ and FG, right? Those are the FJ and G are the two rules that we need to apply here. So MG need to be together, FJ needs to be in this order. So what are the options here? Well, the options are in this case here you don't have MG is either here or there, right? If MG is here, then you have FJ here. If MG is here, then you need to have FJ here. So those are the options for this option. On this configuration, there is not enough room for MG here. So MG is going to be on either here or there. And then your F is going to move and your J needs to be here, right? So that's for 19. Okay, so what is the question now? Which of the following is a pair? My goodness, this is annoying. Which of the following is a pair of models that could be assembled not necessarily in the order given on lines whose number are consecutive, so just one to another. So which ones can be next to one another in one order or the other? Okay, so let's look. G and H. Can G and H be one close to another? Here G cannot be next to H because M is necessary to be next to it. Here again G needs to be far away from H, so A is not the right answer. And then second B answer is G and J. G and J, can they be together? Not here. And G and J not here. So they cannot be next to one another. What about C, H and J? Yes. Here is a possibility for them to be together. They can be together. So C is your answer. Okay, let's move on. Move on to 20. What does 20 tell you? There can be at most how many lines between the lines on F and the lines for F, the line for F and the line for J. There is a symmetry here between the two cases, so we don't have to look at both cases. We can look only at one case where H is at one of the extremities. So let's look, for example, at the one where H is first. You could look at the ones in which F is second. So if F is here, then with F, and then this is where J can be 1, 2, 3, 4. If you want to check, but because of the symmetry, there is no reason to believe that the situation is going to be different. If you put H here, then you're going to put F first, and you're going to have 2, 3, S. And the further away is where J can be is here. Your M, G, and K would be in those slots. Again, 1, 2, 3, 4. So 4 is the answer, which is the answer D in this case. So let's move on to 21. Move on to 21. If K is on line 2, so let's. K is on line 2. So again, I think that the most reasonable thing to do here is to split. So in one case you have HK, S, like this, and on the other case we have you have pum K, pum S, pum H. Okay. So what happens for us? Remember, we've got mainly FG together and FJ as your main rules. So if this is the configuration we have here, then we need F here, and then MJ together and G. So MG together and J that goes around. If we are in this configuration, then MG actually need to be here. I could put them in there actually, because that's the only two slots option we have. So MG needs to be here, F needs to be here, and J needs to be here. So What is the question now? If K is assembler than 2, which of the three must be true? F is answer A. F is lower number than S. F before S, F before S. That's your answer. Yes. Okay, then 22. If G is assembled on number 1 less than F, then now what we have is, instead of MG like this, we have MGF, right? They are all together, those three are together, and then there is G. All right, so let's look immediately at what this is going to, what is it going to look like when we add this to our diagram, our main diagram. Again, we're going to split. First option, H, S, 1, 2, 3. Can we fit this? No, because we don't have 3 room and then another room. So this is actually impossible. So H needs to be on 7s. So we're going to have 1, 2, 3, S, and this, and now we need M, G, and F here, and J and K are going to be in one of those two. So this is what needs to happen. Okay, so what is the question? Then which of the following must be true? F on line 3, absolutely yes. So by making my inferences immediately after reading the completion question, usually finding the answer becomes almost trivial. Instead of trying out things, I'll just draw my consequences, my inferences, and then I'm pretty much done. Last question for the game, 23. Again, a completing question, so we need to have a new diagram. If M is assembled on line 1, so F on line 1, so we know immediately that H is on 7, obviously. And what do we know else? We know that F needs to be here because it needs to be before J, and so K and J are going to be in one of those two. Oh, actually, you could have also another option, which would be K here and FJ, sorry. So that's another option. So that would be M, J, S, H. Or, so those are your two options for number 23. Okay, so which of the following could be true? Could it be true that F is assembled 1 lower than H? F1 lower than H, no. F1 lower than H, no. F1 lower than K. F1 lower than K, no. F1 lower than K, no. Answer C. G assembled 1 lower than J. G 1 lower than J, no. G, J, no. Answer D. G assembled, 1 lower than K. GK, yes. There we go. So that was D. So there you go, you're done, and my computer still wants to go to sleep. So you're done with this one. So that was, again, I think, so this is the kind of diagrams you want to do. You want to keep in mind your main rules, the important rules. You do need to split your diagram from time to time to make it clearer, especially when you have a clear case like this. When you have a symmetry, you don't want to do both. You want to do just one side because there is no reason to do both sides. And also drawing your inferences from the rules before you even look at the question is oftentimes very efficient, because then the answer is obvious. You don't have to figure out each of the answers. That's it. So have a great weekend. Work hard. I'll see you on Wednesday.